Revision of exponents and powers. Laws of exponents. To understand this concept, let us take these questions one by one. Simplify and express the result with positive exponent. So you have to simplify it and write the answer in positive exponent. So let us take this question first. 2 raised power minus 7 divided by 2 raised power minus 9 whole into 2 raised power minus 4. So here you can see the bases are same. So I am using this division law here where the bases are same. That is a raised to power m divided by a raised to power n, that is equals to a raised to the power m minus n. So this is the law, we are going to use it here. So your a value is 2, m is minus 7 and n is minus 9. So what do you get here? You get here 2 raised to the power m minus n. Your m is minus 7, minus of n here is minus 9. So this is minus 9 into 2 raised to the power minus 4. So what do you get here? Minus into minus will become plus. This is 2 raised to the power minus 7 plus 9 into 2 raised to the power minus 4. So what do you get here? 2 raised to the power 2, that is 2 square into 2 raised to the power minus 4. Now the bases are same again. So we are going to use this law here. A raised to the power m into a raised to the power n. So a raised to the power m plus n. And the bases are same, powers are added up. So here the bases are 2, the base is 2 and the powers are 2 and minus 4. So you have to add the powers. So 2 raised to the power 2 plus of minus 4. So you get here 2 raised to the power minus 2. So it says express the result with positive exponent. Here the exponent is negative, minus 2. That means you can take it in the denominator and you will write it as 1 upon 2 raised to the power 2. So I have used this law. A raised to the power m, a raised to the power minus m, that is equals to 1 upon a raised to the power m. So I have used this law here and have rewritten like this so that the exponent becomes positive. So you have got 1 upon 2 square. That is the answer for this question. Now let us take this question. So here you have 2 raised to the power minus 6 into minus 7 whole square. So here you can see neither the bases are same nor the powers are same. So to apply the laws of exponents, you need to make either base same or power same. I am going to make the power same here. So I am going to rewrite this as 2 raised to the power minus 3 whole square. I have used this law here. A raised to the power m into n is equals to a raised to the power m whole raised to the power n. So here a raised to the power mn, this form is here 2 raised to the power minus 6. Then I have rewritten it as a raised to the power m whole raised to the power n. That means here m value I am taking here as minus 3 and n value is 2. So minus 3 into 2 is minus 6. Now let us continue writing it into minus 7 whole square. Now here the bases are different, powers are same. So now I am going to use this law here. A raised to power m into b raised to power m is equals to a into b whole raised to the power m. So here a is 2 raised to the power minus 3, b is minus 7 and m is 2. So ab whole raised to the power m. So I am going to rewrite like this. So that is equals to 2 raised to the power minus 3 into minus 7, this whole raised to the power 2. So I have rewritten like this. Now here I am going to use another law here, that is a raised to the power minus m is equals to a raised to 1 upon a raised to the power m. Taking this in denominator, so this exponent becomes positive. So here I am going to use this law here and simplify it further. So this is minus 7 upon 2 raised to the power 3. This is whole square. So I am going to use this law now. A raised to a by b whole raised to the power m is equals to a raised to power m upon b raised to the power m. So your a here is minus 7, b is 2 raised to power 3, m is 2. So I am going to rewrite like this. So that is equals to minus 7 whole square upon 2 raised to power 3 whole square. So here I can simplify this further using this law here, a raised to power m n whole raised to power m into a raised to power mn is equals to a raised to power m whole raised to power n. It is written like this here. I am going to simplify it and rewrite like this. So 3 into 2 is 6. So this is equals to minus 7 whole square upon 2 raised to power 6. Now let us take this question. Minus 3 upon 7 whole square divided by 7 upon 3 whole raised power 12 upon minus 4. So you can simplify this power further by dividing both numerator and denominator by 4. So in denominator you get minus 1. In numerator you get 3. So I am going to rewrite this as minus 3 whole square upon 7 square. I have used this law here. A by B whole raised to the power m is equals to a raised to power m upon b raised to power m. So here a is minus 3, b is 7, m is 2. So a raised to power m is minus 3 whole square, b raised to power m is 7 whole square, that is 7 square. So this is divided by, I am going to use the same law again. So a raised to power m is 7 raised to power minus 3 upon 3 raised to power minus 3. Now I am going to change division to multiplication so that we can make the base same. So this is minus 3 whole square divided by 7 square into, when you change division to multiplication, you have to take the reciprocal of the second number here. This is the number. So then we can rewrite this as 3 raised to power minus 3. The denominator goes in numerator and the numerator comes in denominator. 7 raised to power minus 3. Now the bases are same. When the bases are same, powers get added up. So a raised to power m plus n. So here minus 3 whole square, we have it here minus 3 whole square. I can rewrite the same thing as 3 square because minus 3 whole square means minus 3 into minus 3. So that gives you 9, and 3 into 3 also gives you 9. So I can rewrite minus 3 whole square is equals to 3 square. So I am going to write this as 3 square into 3 raised to power minus 3 upon, here you have 7 square into 7 raised to power minus 3. So now using this law I am going to simplify it. So here when the bases are same, powers will be added up. So 2 plus of minus 3, and here you get 7 raised to power 2 plus of minus 3. So what do you get here? You get here 3 raised to the power minus 1, and here you get 7 raised to power minus 1. So I am going to use this law here now. A raised to power minus m, this is equals to 1 upon a raised to power m. So here a raised to power minus m, here it is 3 raised to power minus 1. When it goes in the denominator, the minus m become plus m. So minus 1 will become plus 1. So you get here 3. Now the same law I can rewrite it as a raised to power m is equals to 1 upon a raised to power minus m. So here it is a is 7, m is 1. So this, when it goes in numerator, minus m becomes plus m. So here minus 1 will become plus 1. So this is 7. So the answer for this question is 7 upon 3. Now let us take this question, solve for x. So you have to get the value of x here. So here you can see 3 into 3 raised to power 5x divided by 9 raised to power 2x is equals to 1 upon 27. So to apply the law here, I have to make the base same or the power same. I am going to make the base same, and all the base I will make it as 3 because 9 can be expressed as 3 square and 27 is expressed as 3 cube. So I am going to rewrite this as, let us add the powers here because the bases are same. So I am going to use this law here. and simplify it further this. So this is 3 raised to power 5x plus 1 in the numerator. When the bases are same, powers get added up. Divided by, I am going to write 9 as 3 square raised to the power 2x. So that is equals to 1 upon, this can be written as 3 cube. So using this law, a raised to power m whole raised to power n is equals to a raised to power mn. So I am going to use this law here to simplify this further. A raised to power m whole raised to power n is equals to a raised to power mn. So this form is written here. I am going to write like this, means you have to multiply the powers here. So what do you get here? Here you get 3 raised to power 5x plus 1 upon 3 raised to power 2 into 2 is 4x. That is equal to 1 upon 3 raised to power 3. So I am going to simplify this further. So I'll bring the numerator in denominator. So the plus will become minus. So this is equals, this I am writing it here. So 1 upon, this comes in the denominator. So 4x, when it comes from numerator to denominator, this becomes minus. So this is minus of 5x plus 1 is equals to 1 upon 3 raised to power 3. So this side is equals to this side. That means this is equals to 3. So if you simplify this further, 4x minus 5x, you get here minus x, and minus and plus is minus. So you get here minus 1 is equals to 3. So you get x is equals to, when you take it to the other side, minus x is equals to, this becomes plus 1. So x is equals to minus 4, because 3 plus 1 is 4. You multiply both the sides by minus 1, you get here x is equals to minus 4. Evaluate. So you have to evaluate 7 raised to power minus 1 plus 3 raised to power minus 2 plus 6 raised to power minus 2 whole raised to power 0. So do you really need to simplify this and calculate what is the number after solving this? No. You can straight away use this law of exponent, that is, any number raised to power 0 gives you 1. So when you solve this, you will get some number, that number raised to power 0. So any number raised to power 0 is equals to 1. So using this law of exponent, a raised to power 0 is equals to 1, you can straight away write down the answer for this is 1. Standard form. Any number can be expressed as a decimal number between 1.0 and 10.0, including 1.0, multiplied to the powers of 10. Such form of a decimal number is called as standard form. So, for example, 3.16 into 10 raised to power 3. So, this is a decimal number between 1.0 and 10.0 multiplied to the powers of 10. The power can be positive number or it can be a negative number. Let us take the question on standard form. Express the following numbers in standard form. So you have to express these numbers in standard form. So here the decimal point is here. For the number to lie between 1.0 and 10.0, it should be, the decimal point should be here. So what will you do? You have to shift the decimal points towards right hand side. How much you have to shift? 1, 2, 3, 4, 5, 6. That means if you multiply this by 10 raised to power 6, the decimal point will come here. But the number should not change. So if you are multiplied by 10 raised to power 6, you have to divide also by 10 raised to power 6. So when you multiply by 10 raised to power 6, decimal point will come here. So you will have 8.37. And in the denominator you have 10 raised to the power 6. So it should be expressed as decimal number multiplied to the powers of 10. So here the power of 10 is there, but it is in the denominator. You have to take it in the numerator. So I am going to rewrite this as 8.37 into 10 raised to power minus 6. I have used this law. A raised to power minus m is equals to 1 upon a raised to the power m. So when you take this in numerator, this m becomes negative, minus m. So here it is plus 6. When it goes in the numerator, it becomes minus 6. So this is the standard form. You have expressed this number as 8.37 into 10 raised to the power minus 6. So this number is between 1 and 10 multiplied to the powers of 10. Now let us take this question. The decimal point for this number is here. For this number to lie between 1 and 10, the decimal point should be here. So how much you have to move towards left? 1, 2, 3, 4, 5, 6, 7. So you have to move the decimal point towards left by 7 digits. So to do that, you have to divide this number by 10 raised to the power 7. So if you have divided this number by 10 raised to the power 7, you have to multiply also by 10 raised to the power 7 so that the number does not change. So when you divide this number by 10 raised to the power 7, decimal point will come here. So you will get it here 3.186 multiplied by 10 raised to the power 7. So you have expressed this number as this decimal number between 1 and 10 multiplied to the powers of 10. Express the following numbers in usual form. So you have to express 4.5 into 10 raised to the power 4 in usual form. This is the standard form given to you. So here 4.5 is multiplied by 10 raised to the power 4. 10 raised to the power 4 means you have to shift the decimal point towards right hand side by how many digits? 4 digits, because the power of 10 here is 4. So let us move it. So here the decimal point is here now. So I am going to move it now. So this is 1, 2, 3, 4. Initially it was here. So after multiplying by 10 raised to the power 4, the decimal point will move 4 digits towards right hand side. So this is 1, 2, 3, 4. So the usual form for this number is 45,000. Now 3.02 into 10 raised to the power minus 6. I can rewrite this as 3.02 upon 10 raised to the power 6. So I am going to use this law. A raised to the power minus m is equal to 1 upon a raised to the power m. So here 10 raised to the power minus 6, when it comes from numerator to denominator, it is 10 raised to the power 6. So now you have to divide this number by 10 raised to the power 6. Dividing this number by 10 raised to the power 6 means you have to move the decimal point towards left hand side. By how many digits? 6 digits, because the power of 10 here is 6. So let us write it down now. So here it is 302. You have to move the decimal point 6 digits towards this side. So when I move it here, it is 1. Then 2, 3, 4, 5, 6. So you have moved it 6 digits towards left hand side. You can see initially it was here. So 1, 2, 3, 4, 5, 6. So this is the usual form for this number.